Coral reefs are one of the most biologically diverse ecosystems that house up to 75% of marine fish species. They are made up of hermaphroditic corals, which are the reef-building corals, and live in a mutualistic relationship with microalgae that give the corals their vibrant colors. Corals are living organisms made up of either a hard or soft calcium carbonate skeleton belonging to the phylum Nigeria. Bleaching is a rising threat to corals because of various human and environmental factors. During bleaching, zooxanthellae are expelled from the corals, leaving behind a stony white calcium carbonate skeleton. Coral bleaching can occur from elevated temperatures, changes in salinity, irradiance, and even pollution from human products such as sun cream. In extreme cases, coral bleaching can even cause death to an entire coral colony. It also affects coral community structure. It can inhibit coral growth and coral fertilization.
This is a problem because approximately 1 billion people rely on coral reefs for their incomes, so any damage done to these reefs not only affects the people that live there and their livelihoods, but also numerous marine species that can be found in these ecosystems. Pollution in our oceans is a continuously growing problem. In 2010 alone, 8 million tonnes of plastic waste ended up in our oceans. That's a 14% increase since 1975. This causes many problems for our oceans, and we still don't know where 99% of this waste ends up.
However, a recent study by Lam et al. In 2018 reported that corals that had contact with plastic had an increased likelihood of contracting disease from 4% to 89%.
It's thought that light and oxygen are being prevented from reaching the corals, which are essential for their survival. Other pollutants are also finding their way into the oceans, such as runoff of fertilizers from farmland and cosmetics such as sun cream. Fertilizers increase the nitrate concentration in the water, which isn't harmful to the corals unless they are also introduced to extremes of light or heat. Sun creams are particularly damaging to hard corals, even in small quantities, because they filter out the UV rays that zooxanthellae need in order to create their own food. The UV filters in sun creams can cause viral infections in corals, which cause deformities in the soft tissues and encase coral larvae in their own skeletons, killing them. This may play a significant role in the bleaching of hard corals, where there is a large human population and a high frequency of water-based sports.
Although the most prevalent cause for bleaching in corals, temperature is not the only factor affecting these organisms, and it is not even the most dangerous one as an individual stressor. Due to the fact that sclerotin and corals live near their upper thermal tolerance, small elevations in the water temperature, such as 1 to 2 degrees Celsius, will negatively impact them, increase their stress levels, and at worst, lead to death. The threat of bleaching to corals is increased when temperature is paired with other factors affecting their health, such as UV radiation, pollution, diseases, and salinity fluctuations. Another cause for bleaching is solar radiation, coupled with thermal elevation. The exact effect of irradiance as an individual stressor is unknown due to the difficulty of measuring it in situ. Symbiotic corals experienced an increased partial pressure oxygen as a result of photosynthesis. Hyperoxia and exposure to solar radiation coupled with high temperature produce active forms of oxygen in the zooxanthellae. The excitation energy absorbed while in the presence of active oxygen leads to the production of hydrogen peroxide in different targeted cells. The oxidative stress caused by this leads to the photoinhibition of photosynthesis, which in turn will lead to bleaching. Prolonged exposure to bleaching has many consequences, such as a complete change in the community structure, inhibition of skeletal growth, inability to shed sediments, to resist diseases, and competing species. In extreme cases, it can cause bioerosion, death of an entire colony, or the complete disappearance of the reef. Some studies, however, propose bleaching as a way for adaptation. Corals can obtain new zooxanthellae after bleaching, which have different ecological and physiological capabilities.
Scleractinian corals, which are the hard, stony, reef-building corals, are stenohaline and thrive in salinity levels between 32 and 40 psu. They are bleached when salinity concentrations changes suddenly. A sudden change in salinity occurs when there is an increase in the amount of fresh water entering the sea. During weather systems such as cyclones, there is an increased amount of torrential rainfall which enters from the rivers as flood plumes, inundating the corals. Freshwater flooding suddenly decreases the salinity of seawater, causing bleaching to corals that are in closer proximity to the shore. This causes the corals to appear bleached as their stony white calcium carbonate skeletons are exposed. Salinity affects the photosynthesis of zooxanthellae and would therefore mean that the coral would receive less energy and nutrients. The coral would now be an unsuitable host for the algae and they would be expelled, leaving the coral bleached. Coral bleaching inhibits the growth of corals as they do not receive the necessary energy to build their calcium carbonate shells from the zooxanthellae which have been expelled. Bleaching may inhibit some species of corals and their relative abundances. This is because the reproductive cycle is disrupted and effective fertilization is prohibited.
Corals play an important role in sustaining human development. If corals are bleached, we will not be able to benefit from them anymore. Coral reefs generate revenue for their countries via tourism, fisheries, and recreational activities. Once the algae are expelled due to coral bleaching, the reefs will not be as attractive. This colorful ecosystem will now be plain and white, and countries will lose revenue, seeing that people will be uninterested in these plain corals. Bleached corals would not be a suitable base for a community of fish, and they too may migrate. This may ultimately result in the loss of jobs for people whose work depend entirely on these reefs. Dawn et al. In 1996 discovered that approximately $1 billion is generated annually by the Great Barrier Reef. A country could lose a big portion of that money if the reef takes a long time to recover or doesn't recover at all.
Corals are the base of coral reef ecosystems, and without corals, the ecosystem would not be able to thrive. Goldberg in 1999 found that coral reefs have a crucial role in shaping the ecosystems that have dominated tropical oceans for the past 200 million years. Bleached corals can't effectively provide a habitat or shelter for other marine organisms. This results in species migrating to different areas and to find new, healthier reefs, which causes a reduction in species diversity in the original area. Due to migration of some species, a disruption in the predator-prey relationship occurs as the species makeup of the reef has changed.
75% of all coral species reproduce sexually by broadcast spawning, which is a mass synchronization event which happens only once or twice a year. However, bleaching affects coral reproduction. Goldberg 1999 gives evidence of this, as he found that temperatures in which corals bleach also slow the development of gonads within corals and interrupt a number of key processes like fertilization. If there is a decrease in the number of gonads that are developed, it would decrease the success of the mass spawning events and in the end decrease the coral reproduction rates. Corals are unable to obtain the byproducts from the photosynthesis of zooxanthellae when they have been expelled. These algae translocate excess assimilated carbons to the coral polyp. Since coral calcification is directly linked to photosynthesis of zooxanthellae, coral growth is reduced when there is coral bleaching.
On a brighter note, corals can recover if conditions become more favorable. After the drastic reports about the mass coral death on the Great Barrier Reef earlier last year, the reality is that only about 3% of the corals surveyed in the affected areas have died, with most of the corals being mistaken for bleached, when in fact they were only fully or partially pale. People have also been working on ways to reduce the amount of plastic that ends up in our oceans with projects such as Seabin and Mr. Trash Wheel. These projects are working constantly to remove all sorts of rubbish in the reef on harbors and docks, reducing the amount of plastic waste that ends up in oceans. The company Lush has an environmentally conscious plan to remove 2 tons of rubbish from the oceans in order to make their packaging. Various governments have also placed bans on microbeads in cosmetic products to reduce the amount of plastic waste.
Considering freshwater effects on coral reefs because of decreased salinity, building wastewater systems to direct land runoff away from coral reefs could help combat this. Ultimately, educating people about the harmful chemicals in cosmetics and plastics that are released into the ocean will go a long way in maintaining coral reefs. To have a greater understanding of the world we live in is to have a greater responsibility to protect it.